Hey all, welcome back, my dear students. How are you all? I hope you all are fine. This is Ruchika Chugh, your maths expert, and today we are going to discuss all about trigonometric ratios and functions. In the last class, we discussed about the definition of trigonometry. That was, it is the branch of mathematics that deals with the relationship between sides and angle of a right angle triangle, and these sides are taken in the form of ratios, and these ratios are known as what? Trigonometric ratios. Let's have a look on its definition first. The ratios of the sides of a right angle triangle with respect to one of its acute angles are called trigonometric ratios or T ratios. Let's take a right angle, say triangle ABC. Here you can see angle B is marked with 90 degree. Angle B 90 degree means the other two angles means angle A and angle C all together they are also 90 degree. Why? The reason behind this is angle sum property of triangle, that is 180 degrees. It means individually these two angles are less than 90 degree. If they are less than 90 degree means they are known as acute angles, right? So in trigonometry we are taking ratios in such a way that they will be related to any one of acute angles. To have some more understanding about trigonometric ratios, let's have the triangle in more clarity with some activity. So are you ready? Let's get started for the activity now. Here you can see two triangles. See them carefully. Find out the similarities and differences. Let's check out the similarity and differences by taking these two triangles as first triangle and second triangle. If we talk about similarity first, then the first similarity is that name of these two triangles are same. That is triangle DEF. Isn't? This is the first similarity. Second similarity, you can see that angle E in both of the triangles are 90 degree, right? And third similarity is that side opposite to 90 degree, which is hypotenuse, is DF in the first triangle as well as in the second triangle. So we can say that DF is hypotenuse in both of the triangles. These are the three similarities. And when we talk about differences for triangle 1 and triangle 2, so see both of the triangles carefully again, and what are the differences. In both of the triangles you can see there is a special letter which is for angle F in first triangle and for angle D in second triangle. This letter is a Greek letter which is known as theta, and theta we use in trigonometry for denoting angles, any one of the acute angles, right? And in both of the triangles theta are marked for different angles. In first triangle theta is marked, that I am taking as first difference. First difference for theta in first triangle, it is marked for angle F. Angle F is theta in first triangle, and in second triangle angle D is theta, right? Now check out the second difference. You can see both of the triangles are having 90 degree as angle E. Theta in first triangle is F and in second triangle is D. Now what about the third angle in both of the triangles? That is 90 minus theta. Why 90 minus theta? Reason is angle sum property of triangle, and you can see in both of the triangles the differences in terms of this angle, that is 90 degree minus theta. In first triangle it is angle D, isn't? And in second triangle 90 degree minus theta is which angle? That is angle F. So here we have found two differences. Now check out some more differences. See difference number 3. If you see the triangles carefully again, then the side opposite to theta is marked as perpendicular. In first triangle, this perpendicular is DE, but in second triangle, opposite to theta, perpendicular is EF. So we can write What? In first triangle we can write DE is perpendicular. And in second triangle we can write EF is perpendicular. Isn't? Now the last difference. Last difference, you can see the remaining side. Now remaining side means base. In first triangle the base is EF. Yes. And what is the base in second triangle? The base in second triangle is DE, isn't? So here we have done with the activity and see the conclusion now. The conclusion for this activity is that we are able to find the three sides of a right angle triangle as hypotenuse, perpendicular and base according to the angle which is chosen for finding the problems in trigonometry. Sometimes we take base as the bottom line in a right angle triangle and vertical line is perpendicular, and the choice of selecting these sides as this way is totally wrong. Right? This is all myth. Never ever take the bottom line as base and vertical line as perpendicular. Then what is the method for finding base and perpendicular? Method is here in this activity. In this activity we have concluded that first, the very simple, the side opposite to 90 degrees always hypotenuse, that is the always true. But when we talk about base and perpendicular, then the perpendicular is that side which is always opposite to theta or the angle which we are considering in trigonometric ratio, right? And the remaining side will be taken as base. So this is all about the conclusion of activity. Let's move to trigonometric ratios again. Trigonometric ratios are the ratios which will be in the form of ratio of any two sides of a right angle triangle. Now there are three sides in a right angle triangle. They are perpendicular, base and hypotenuse. So can you frame the ratios from these three sides? It is very simple. First we can take P two times and it can be taken in the ratio form with other sides, base and hypotenuse. Here we have found two ratios, P by B and P by H. Same we can do with the remaining sides. Means base two times and hypotenuse two times. Base two times, one time can be taken with ratio with P and second time can be taken with hypotenuse. Similarly, H by P and H by B. Isn't simple? This way we have taken all the ratios in all the form. Nothing is left there, right? And if we count, then there are 1, 2, 3, 4, 5, 6. There are total 6 ratios, right? These 6 ratios are there in trigonometry as P by H, B by H, P by B, H by P, H by B, and the last is B by P. And do you know these all ratios are related with special names in trigonometry? These names are known as trigonometric functions. Then how many functions will be there for these 6 ratios? Obviously 6. And these functions are, first is sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and the last is cotangent theta. These are the names of trigonometric functions which you all have to remember. And see one more thing here, every function is written with angle. It can be theta or any angle which we can use as the vertices of triangle. It can be any form, but we have to make sure that every function should be written with angle over there, right? These all functions are having their short name also, so we can speak their short names like sine theta, cos theta, tan theta, cosec theta, secant theta or sec theta, cotangent theta as cot theta, right? These all 6 trigonometric functions are having relation with 6 trigonometric ratios. But before discussing trigonometric ratios, let's discuss their interrelation. They are related to each other also. Among all 6 functions, sine theta and cos theta are the basic functions, and other functions can be written in terms of these two functions as tangent theta, tan theta, You have to remember this. It is the ratio of sine theta to cos theta, right? As sine theta and cos theta, they are the basic functions. So first we talk about the relation of tangent theta with these two. Now next we talk about after tangent as cosec. Cosec means cosecant theta. It is the reciprocal of sine theta. Sine theta reciprocal means 1 by sine theta, isn't? Now the next one is sec theta, means secant theta. And can you guess? It can be the reciprocal of, yes, you are correct, cos theta. So we can write 1 by cos theta. And the last one is cotangent or cot theta. It is the reciprocal of basically tangent theta, means 1 by tangent theta. And what was tangent theta? It was sine theta by cos theta. So we can say that cot theta is the reciprocal of tan theta, means cos theta upon, yes, sine theta. Isn't simple? Now we have to relate all these 6 functions with 6 ratios. Are you ready to get the relation? Yes. So here is the relation. Sine theta is having relation with p by h, means perpendicular upon hypotenuse. Cosine with b by h, tangent with p by b, cosecant with h by p, secant with h by b, and cotangent with b by p. I know you all are getting scared of all these relations. Don't worry, I'm the maths expert in front of you. I'm going to give you a trick, and the trick is to remember T ratios and trigonometric ratios. What we need to do? We need to just remember a mnemonic, and the mnemonic is having just 3 lines, and the 3 lines are very simple. The lines are: some people have curly brown hair, turned purple blue. And here you can see every word is having initials with different color, right? So what is the meaning of S in sum? It means sine. Yes. P means perpendicular. H means simple hypotenuse. So it means sine theta. We need to write always with trigonometric function, right? Never ever miss angle. It can be theta or any letter, right? Sine theta is P by H. Curly brown hair. Curly for C. Cos theta. Brown means base. Hair means hypotenuse. So cos theta is having ratio B by H. Isn't simple now? Yes. Turned means, yes, you are right, tangent theta. P perpendicular, yes, and B base. So tangent theta, yes, equal to P by B. Now you might be wondering that this trick is for only 3 functions. What about remaining functions? For that, though, I already have given you formulae, so we can derive from there. What is that? After sine theta, cos theta, and tangent theta, we are left with 3 more functions. They are cosec theta, which is the reciprocal of, yes, sine theta, right? And sine theta is what? P by h. So cosec theta will become simple h by p, isn't? Next one is sec theta, which is the reciprocal of, yes, cos theta. Cos theta is having ratio b by h. So the reciprocal of cos theta means h by b. Very simple. Now the last one is cot theta. It is the reciprocal of tan theta. What is the ratio of tan theta? P by B. So it will become B by P. So it is all about the trick of remembering trigonometric ratios. So here is the conclusion now. Sine theta, P by H. Some people have curly brown hair, turned purple blue, P by B, right? And cosecant theta is the reciprocal of sine theta. P by H will become H by P, right? Secant theta is the reciprocal of cos theta. B by H will become H by B. Simple. Cotangent theta is the reciprocal of tan theta. Tan theta is P by B. So it will become B by P. Okay. So here we have got the understanding in a better way. Let's have a quick recap with match the following. Are you ready? Let's match the trigonometric functions with trigonometric ratios. Let's see how much understanding you have now, right? Sine theta, some people have p by h. Where is p by h? Here it is, right? Cosine theta, curly brown hair, B by H. Here it is, B by H. Tangent theta, turned purple blue, P by B. Here it is, P by B. Cosecant theta is the reciprocal of sine theta. Sine is P by H. So cosecant will become H by P. Here it is. Yes, secant theta is the reciprocal of cos theta. Cos theta is what? B by H. So secant theta will become H by B. And the last cotangent theta is the reciprocal of tangent theta. Which one is P by B? So the reciprocal of P by B will become B by P. So here we have done with the match the following and got the understanding of trigonometric functions and ratios. Yes, in a better way. Now what are you waiting for? Let's solve some questions, and here the question is there in front of you. Let's see the statement. In triangle ABC, right angle at B, the value of AB is 24 centimeter, BC is 7 centimeter. We need to determine the two parts sin A cos A and the second part sin C cos C. This time theta is not there. Theta is not there. Some angle is there in the form of letter, capital letter. So that will be considered as theta, and we have to choose the perpendicular and base according to the given angles, right? Let's make the triangle first. Here it is the triangle ABC, which is right angle at B. You can see here. Here AB is 24 centimeter, right? BC is 7 centimeter, and we are supposed to determine sine and cos for different angles, and you know already the ratio of sine is some people have P by H. We already have perpendicular and base with us, but how to find hypotenuse? That is missing here. You know that is very simple to find by using, yes, Pythagoras theorem. So first of all, we can find the value of AC. That is AC square is equal to sum of square of other two sides, means AB square plus BC square. Isn't? So AC square can be calculated by putting the value of AB, that is 24 square, plus BC square means 7 square. How much is the value of 24 square? That is 576, and 7 square is 49. Let's add 576 and 49. How much is the sum? 6 plus 9 is 15. We will write 5. 7 plus 4, 11, and 1, 12. We will write 2. And 5 and 1, 6. So here we have got AC square as 625. Then how much AC? It is square root of 625. That is, yes, 25 centimeter. So here we have got the value of AC as 25 centimeter. Now we can find the value of these different parts. So let's get started for finding these different parts. The triangle is there with us. The three sides are also there available to us. So we can find the first part. How? Sin A and cos A by applying their ratios. Sin A. What is the ratio of sine? That is some people have P by H. Cos A means curly brown hair, B by H. So here we have got the ratios. Let's put their values. But before putting values, we need to check the angle. Here they are talking about angle A. Here is the angle A. Opposite to angle A would be, yes, perpendicular. Then opposite to 90 degree is hypotenuse, and the remaining side is, yes, base. So here we have found the perpendicular, hypotenuse and base according to the angle which they are asking, right? So what is perpendicular? Let us repeat. Perpendicular is 7, hypotenuse is 25, and base is 24, hypotenuse is 25. So here we have found the answer of first part. In the same way, we can find the answer of second part. But in the second part, we have to take what? Different angles. So what are the different angle in second part? You can see angle C. So if we are taking angle C, then the side opposite to angle C will be taken as, yes, perpendicular. Side opposite to 90 degrees always hypotenuse and the remaining one is base. So in the second part they are asking us to find sine C and cos C. Ratios are same. Some people have curly brown hair. So let us find the values now when the angle is taken as C for trigonometry. Perpendicular is this time 24, hypotenuse is the same always, and base is 7, hypotenuse is 25. So the final answer for B part, 24 by 25 and 7 by 25. So after solving this question, I have a quiz for you. Are you ready? Let's start solving the quiz. This is quiz time, right? So here we have got the first question. What is that? It's very simple. Identify the hypotenuse in the given triangle ABC. See this triangle ABC very carefully and check out the hypotenuse. That is the very simple. The side opposite to 90 degree is always hypotenuse. What is hypotenuse? AC. Option number C. Yes. Moving to the next question in our quiz time. Identify base in the given triangle DEF. So you can see the triangle DEF and this time they are asking base. Let us find that. Side opposite to 90 degree is hypotenuse. Side opposite to theta is perpendicular and the remaining one is, yes, base. So which one is base? DF. Option number C. Okay. Isn't easy? Trigonometry? Yes. Question number 3 in quiz time. This time we have to identify perpendicular. How to find perpendicular? Very easy. See the triangle PQR and find out the theta. Theta is at P. Side opposite to theta is perpendicular. QR. Option B. Very easy. Moving to the next. Question 4 now. Which one of the following is not? Yes, this time they are asking for not the base. Every time we have to read the statement very carefully, right? So we are not finding base, we are finding not the base this time of the given triangle MNO. See triangle MNO? This is 90 degree. Opposite to this is hypotenuse. Opposite to theta is, yes, perpendicular, and the remaining one is base. So if there is a base, then we have to answer Mn. But this time we are not supposed to answer for the base. We are supposed to answer for not the base. So which two sides are not the base? First is MO. It is not the base. And second is NO. 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 Not the base. Yes. So these two sides are not the bases. So MN, it is the base. So it cannot be the option. MO, yes, NO, yes. How can we give two options? But yes, here you can see D option is carrying the option B and C all together. So the correct answer is option D, right? So now moving to next question, that is question 5. Let's read the statement first. Yes, in a right triangle ABC, okay, the right angle at B. So B is 90 degree. Fine. Which of the following is true about the other two angles A and C? This though we already have discussed. If in a right angle triangle, angle B is 90 degree, then the other two angle altogether will become 90 degree. Individually, they will be less than 90 degree. Means, yes, acute angles. Let's see the options. First option, there is no restriction on the measure of the angles. Yes, restriction is to there. Both of the angles have to be less than 90 degree. Restriction is there. We cannot say there is no restriction. So option A will not be there. Yes. Second, both the angles should be obtuse. How obtuse? They have to be acute. Less than 90 degree. So this option will also not be there. C option, both the angles should be acute. Yes, this is correct. Let's read the D option also. One of the angles is acute and the other is obtuse. No. These two angles can never be obtuse. Both of the angles have to be less than 90 degree. So yes, option C is the correct answer. Yes. Moving to next question now. Question 6. Which of the following are Pythagorean triplets? Do you know what are the Pythagorean triplets? According to Pythagorean triplets, there are three numbers. Triplets means three numbers. The numbers are considered Pythagorean triplet only when they are following the relation in such a way that square of largest number is equal to sum of square of other two numbers, same like Pythagoras theorem, right? And here you can see the options. Every option is written with centimeter, means they're talking about right angle triangle sides, right? Let's check out, are these sides are the sides of a right angle triangle or not. We have to apply the concept of square of largest side equal to sum of square of other two sides. So if we take option A, 4 centimeter, 6 centimeter, 8 centimeter, largest side would be 8 centimeter. So square of 8 is 64. Okay, it has to be the sum of square of other two side, mean 4 square 16 plus and 6 square means 36. Let's check, are they equal? 64 is equal to 6 and 6 12, 3 and 1 4 and 1 5. Now they are not equal, so we can say option A is not there. Try for option B. Okay, in option B, you can see the three sides as 13, 27 and 30. Biggest is 30, square of 30, 900. Are they equal to the sum of the squares? 13 square means 169 and 27 square is 729. Let's check their sum. 9 and 9 18, 6 and 2 8 and 1 9, 7 and 1 8. No, they are not equal, so option B is also not there. Let's try for C now. The largest is 17. Square of 17 is 289. Is it equal to sum of square of other two sides? 2 square means 4 plus 9 square means 81. No. 4 plus 81, 85. How can it be equal to 289? No. Let's check for next one, that is D. 24. It has to be correct. Actually, all the three options are wrong, so it has to be correct, but still we have to check. 24, 10 and 26. Let's take the square of 26, that is 676, isn't? And the square of 24, 576, and the square of 10 is 100. See, the sum is 676. So we have got finally the Pythagorean triplet as 24, 10, 26. So this is our correct answer. 24 centimeter, 10 centimeter and yes, 26 centimeter. Moving to the next question, and you can see how the difficulty level is increasing, right? So the next question, question 7, if cos A is some angle is equal to 4 by 5, okay, then find the value of, then the value of tan A. We have to find the value of tan A. Okay, let's solve this first. We have given cos A is equal to 4 by 5. What is the ratio of cos? That is curly brown hair. This implies that B by H is equal to 4 by 5. So therefore, can we say that base is 4 and hypotenuse is 5? No, they are in ratio. So base can be written as 4x, Mr. X in maths, and 5x for hypotenuse. And they are asking us to find the value of tan A. And the ratio of tan, turn purple blue, P by B. Do we have the value of P? No. So we are supposed to find the value of P first using Pythagoras theorem. Square root of h square means hypotenuse square minus base square. Hypotenuse means 5x square will become 25x square minus base square means 16x square. Yes, in square root. Subtraction, we'll do subtraction over there and we'll get 9x square. 9x square in square root will become, yes, 3x. So p we have got as 3x and base was already given, that is 4x. X and x will get cancelled and we are left with, yes, 3 by 4. Let's check out the options, and option C, 3 by 4. Yes, so here we have calculated the seventh question in our quest time. Moving to the next question, and yes, difficulty level is increasing. Okay, so let's read the statement. In triangle OPQ, right angled at P, OP is 7 centimeter. Okay, OQ minus PQ is equal to 1. This time the value is not given individually, it is given in relation, and the relation is OQ minus PQ is equal to 1. Okay, and we need to find the values of sine Q and cos Q, right? So let's make the figure first. Figure will look like this, where OP is 7 centimeter and we have got the relation of OQ minus PQ as 1 centimeter, right? So in this type of question, what we do, we consider one of the side, we imagine or we assume one of the side as x, Mr. X. So let's take OQ as x, OQ as x, OQ minus PQ is equal to 1. Then how much is the value of PQ? It would be x minus 1 centimeter. Okay, we have got PQ as x minus 1 centimeter. Now what to do next? After this, we have to apply Pythagoras theorem. Let's apply Pythagoras theorem now. So according to that, square of hypotenuse means x square is equal to sum of square of other two sides means x minus 1 square plus, yes, 7 square. Let's solve it further. X square is equal to x minus 1 whole square. Open this bracket, apply algebraic identity number 2, a minus b whole square. That is a square minus 2ab plus b square means x square minus 2x plus 1, and further 7 square as 49. X square and x square will get cancelled and we are left with 2x is being transposed to the left hand side is equal to 1 plus 49 can be taken as 50. So x is equal to 50 by 2 means 25. So here we have got the value of x. So it means, therefore we can say that OQ is x means 25 centimeter, isn't? And PQ, x minus 1, 25 minus 1, 24 centimeter. And OP was already given in the question as 7 centimeter. So what can we say? We can find the value of sine Q and cos Q. So what is sine Q? Some people have P by H and we have to check out Q. Opposite to Q is perpendicular, that is 7, and hypotenuse is 25. Yes, cos Q, that is curly brown hair, B by H, right? And base is what? That is x minus 1, 25 minus 1, 24 upon 25. So here we have found the two values, sin Q as 7 by 25 and cos Q as 24 by 25. Let's check out the options and it is there in option A. So this is our answer. Yes, so here we have calculated different questions on the basis of trigonometric ratios and functions. Wasn't interesting? Yes, we are going to have more interest, more fun in my coming sessions where we will be covering more topics of trigonometry. For that, you need to watch my coming sessions. Till then, bye bye and take care of yourself.